All right, guys. So we're going to add on to our notes from last class, and we're going to be talking today about rotation. So a rotation on the coordinate plane is one of the trickier things that we do. When we think about a rotation is like a turn. We're taking an image and we're turning it. So we take the image and we turn it 90 degrees. That would be 1/4 turn. Do you see how it changed? This was quadrant 1. When I turned it, now the image is in quadrant 2. 180 degrees, I would take my image and turn it one more time. Now it's in quadrant 3. 270 degrees, I would take it and turn it one more time to be in quadrant 4. We also have two different directions that we can turn this image. Most of the time in math, when you deal with rotations, because we label our quadrants 1, 2, 3, 4, we usually work in a counterclockwise motion. Every once in a while, a question might ask you about a clockwise motion. So in our notes, let's take a quick, let's write down sort of some important ideas. When we talk about rotation, a rotation is a turn. We are taking an image and turning it 90 degrees. We can rotate it counterclockwise, which is the most common, or we can rotate it clockwise. Each of these things have different rules for how we can do them based on how far we're rotating. So we're going to spend some time talking about the different types of rotations. A 90-degree counterclockwise rotation takes a point X, Y, and because it's a rotation, because we are turning something, the X and the Y actually turn places. So instead of X, comma, Y, it becomes our Y value switches places and becomes negative, and the X value stays the same. So for example, if I had a point 4, -2, and I want to know what my image looks like, my X and my Y values need to switch spots. So the 4 used to be an X, now it becomes in the second location. The -2 used to be a Y, now it goes in front, but it also becomes opposite. So this becomes +2, 4. We'll do another one because I know it can be hard. -3, 6. The first thing I do is I flip my locations. I twist my location so it becomes 6, -3. But now I need to make that first number opposite. It becomes -6, -3. 1, 4. I switch locations. It becomes 4, 1. And that first number becomes negative. So that's our first one. 90 degrees counterclockwise means that we would take our image and move it one rotation to the right. Take my image, move it one rotation to the right. If we move it 2 rotations, that would be 180 degrees. It doesn't matter if it's clockwise or counterclockwise here. The way that this works is X, Y becomes -X, -Y. So here, the X and the Y stay in the same spot, but they both become opposites. So 4, -2 now becomes, they stay in the same spot, but both become opposite. -4, +2. So that's our 180-degree rotation. That is the most simple one. The last one is when we have a 270 counterclockwise counterclockwise rotation, X, comma, Y. These would then, again, twist spots. X and Y would interchange to become Y, comma, X, but this time, instead of this first number becoming negative, the second number becomes negative. So for -2, I switch spots, -2, 4, and now the second number becomes opposite. Or if it was -3, 6, they switch spots to become 6, -3, but that second number now becomes opposite, or +3. One last thing to note is a 90-degree clockwise rotation. You can see a 90-degree counterclockwise rotation is actually the same as a 270-degree clockwise notation. So here, if I took this image and move it one quadrant over counterclockwise, I could also take this image and twist it 3 times and end up in the same spot. So a 90-degree counterclockwise rotation is actually the same as a 270-degree clockwise. So at 270 degrees, counterclockwise rotation is the same as a 90-degree clockwise rotation. This is definitely the one where you're going to need the most practice, so be patient with yourself. Try your best. And of course, come to office hours if you need help.